Is your image in Java too big or too small, and you want to resize it by a scale factor that's a floating point? Well, if you do, you should continue watching this tutorial. We're going to need all of these libraries. They'll be related to resizing the image or displaying the image on a JoptionPane. In this tutorial, my main method will have a throws IO exception here, so we don't need to do any try catches, but if you don't want to do a throws IO exception, you need to surround your file handling code with a try catch statement. Let's get into it. If you're in NetBeans, you can right click on your project and go to properties. And here is going to be where your Java project is. I am going to have my image that I'm going to resize in the root directory of my Java project. You can put it wherever you want, just make sure you get the file path correct. So we're going to do private static, buffered image, resize image, buffered image, original image, and float scale factor. It's private static, meaning it can be called anywhere without creating a class, but it's not accessible outside of this class. We're going to return a buffered image, and we're going to take in two parameters, the original image that we want to change the size of, and the scale factor. How much do we want to increase the width and the height by? And it's a float, so it can support a number like 1.2. Next, we're going to do int new width, int original image.getWidth times scale factor, and int new height, int original image.getHeight times scale factor. So we're going to be getting the new width and the new height of what our image would be if we resize it by a scale factor. And we convert them to integers because you can't have something that's half a pixel big. Then we're going to do buffered image, resized image equals new, buffered image, new width, new height, buffered image dot type int argb. So we're going to be creating a new buffered image with our new dimensions, and type int argb is basically red, green, and blue that supports alpha transparency. Then we're going to do graphics 2D g2d equals resized image dot create graphics. So this line is going to get a graphics 2D object from the new image, and graphics 2D is a more powerful version or subclass of graphics that provides more sophisticated control over geometry, coordinate transformations, color management, and text layout. This will allow us to resize our image by a scale factor of a float. Then we're going to do g2d, which is our graphics 2D object, dot set rendering hint dot key interpolation, rendering hints dot value interpolation by linear. So we're going to be setting rendering hints for our resizing operation. The first one, key interpolation, is the key that dictates how image pixels are interpolated, and value interpolation by linear specifies bilinear interpretation, which offers a good balance between quality and performance to image scaling. This is probably the default in many image editing programs like Paint.net, or even when you import something into something like Unity. You can change it to something else, but I'm going to keep it like this. Like if you're doing pixel art, you might want to go for nearest neighbor. Then we're going to do g2d.drawImage, our original image, which is our buffered image up here, 0, 0, new width, new height, and null. So basically, we're going to draw our original image onto the new buffered image, which is our resized image, and we're going to scale it to the new width and height, because in the previous tutorial, we could only multiply by a scale factor that was a whole number, while here we're able to specify exact amount of pixels in width and height, which means we can do a scale factor that's a floating point. And just remember, our graphics 2D is using our resized image buffered image that we made here, and now it's drawing our original image onto it. Once we've drawn the image, we can dispose of our graphics 2D object because our buffered image now has our resized image on it. And therefore we don't need the graphics 2D anymore. Then we're going to return the resized image to where we call this function because we've finished, it's resized. So this code here is our entire main method. Let's break it down. So we do buffered image, original image equals image.io.read, new file, bigdab.png. Here we're just going to be reading our PNG into a buffered image object. Then we're going to do float scale factor, and I'll do 1.0 to start with, so you see the original image, then we'll change it after. Then I'm going to do a buffered image, a resized image equals a resized image, original image, and scale factor. Here we're just calling our resized image function to resize our image. Then we can do ImageIcon equals new ImageIcon, resized image. We're creating the image icon so we can put it on the JoptionPane, and then we can do JoptionPane.showMessage dialog, null, ImageIcon, resized images for little header, and JoptionPane.information message. So here we're going to be displaying the image on the screen. So with all of that, we're going to save our work and hit play. As you can see, it's a big image. It's a screenshot from the Pokemon anime of Poliwhirl dabbing when he's fighting against Kingler. I thought that was quite big, so let's do a scale factor of 0.4. As you can see, the image is quite small. Awesome. Now, I thought that was a bit too small. Let's do 1.2 instead. It's nearly the size of my screen at this point, but I've shown it work. So, thanks for being a great audience, be sure to leave a like and a comment if you enjoyed, and subscribe for more tutorials. Thanks for watching.